Okay, but if you want to find like area under the graph for a rectangle, it's very simple. Let's say I have y equals to, let's say 3, and this is x equals 1. This is x equals to 5. So how do you find this area? We just take length times breadth. Correct or not? So if you have a triangle, let's say the curve like this, we just find area of triangle. If this, we use area of trapezium. But what if the curve is like this? You cannot find the area directly, right? You cannot use triangle trapezium. But what we can do is we can use everyone, are you with me? Alvin, Matthew, we break it up into smaller triangle, like rectangle like this. We just add them up. Hello. Find out what is the area of each rectangle. We add them up, you get the total area. But basically, we break it up into smaller rectangle. We find area of rectangle by 1, you add them up. Okay, I'm just going to go through the example. Self-test you don't have to do because normally they don't test this in the exam. So here we have area under the graph y equals x squared plus 3, h. So what we're going to do is we're going to find the midpoint. For the boundary 1 to 2, I can see boundary 1 to 2 means we're going to draw this line. This is 1. Oh, okay. I don't want to use this ruler. Very hard to draw. I draw like this. Okay, horizontal. This is 1 to 2. So we take the midpoint here. So midpoint of 1 to 2 is what? 1.5. So how do you find the height? We sub inside this formula. Hey, Ryan, Lee, come on. Can you put 1.5 squared plus 3? Somebody, 1.5, sub inside. Sub inside your 1. 1.5 squared plus 3, what do you get? 5.25. So what is this actually? This is your height, 5.25. So now we know this boundary from 1 to 2. What is the width? 1 unit, right? Is it 1 unit? 1 to 2, the unit, the length is, the width is 1. Height is 5.25. What's the area of this rectangle? 5.25. Okay, let me just highlight for you. This area is just 5.25. Okay. Now, the next thing is 5.25 here. How about 2 to 3? 2 to 3, the bar is like this. Okay, so the midpoint is 2.5. So I need you to take 2.5 sub inside here. 2.5 squared plus 3, answer is 9.2. 9.25. Okay, so this bar has height, or this rectangle has height 9.25. So this is your area. Okay, the next one, 3 to 4 is 3.5. 3.5, you square it, you plus 3, 15.25. So this is also 15.25, right? Okay. How about 4 to 5? Okay, just continue drawing this. 4 to 5, the rectangle is here. So 4.5, 4.5 squared plus 3, 23.25. So this is your area. So I need you guys to add up. What's your total area? 5.25 plus 9.25 plus 15.25, 23.25. Okay? So answer is 53. Okay, so this is a way to estimate, but actually it's not very accurate because the bar is quite big. So you can see some of the area here is outside, some are inside. You see? It is an estimation. In this case, Natalie, the length is equal to the area because the width is 1. See, the width is 1. So your area is length times width. My length is 5.25. The width is 1. So the length and area is the same. So like 9.25, you multiply 1, is still 9.25. So that's why it's the same. So, but you know, remember I told you guys this, right? That if you integrate from 1 to 5 of this function, hey, everyone, if you were to integrate your function here, x squared plus 3, 1 to 5, you should get x cubed over 3 plus 3x from 1 to 5. When you sub 5 inside, you get 125 over 3. 3 times 5 is 15. 1 over 3 plus 3. What would you get? Can you count for me? It's 53, 1 over 3. Okay, now this one is not necessary. This is just for checking purpose. Okay, so we know our answer here is quite close, but the accuracy can only be enhanced if we use a smaller rectangle. If I use a rectangle with a width of 0.5 or even 0.1, then the answer will be closer to this answer. Okay. Okay, next one. Okay, so I'm keeping this. Let's move on to the next one. Okay, this one is an explanation. Just now I've already shown you here that if you use a smaller rectangle, right, and let's say I have a curve like this. Let's say each rectangle we have a width of delta x, and the height is y. This is y1. Then I have a second one, also delta x. This is y2. Third one is higher, taller, is y3, also delta x. So my area is basically y1 times delta x, y2 times delta x, y3 times delta x, all the way until yn times delta x. So we can write this as summation of yi delta x. Your I starts from 1 until n. I starts from 1 until n. All this notation no need to know one. So when your delta x is small, approaching 0, we can now use, instead of using this sum, right, we use this symbol, integrate. Basically, this is y, your delta x becomes dx. Lower limit, if this area is bounded from, let's say, a to b here, you can see that. So it's just a to b. So basically, when you write integration a to b y dx, the y represent the curve here. Can you see the boundary here? Dx represent your x-axis. A, b is your limit here. So these four information represent the four boundaries of the area that you're finding. Yes or no? Okay. So let's look at one. Okay, before we go through the example, a couple of things you need to know. If your area is above the x-axis, that's not an issue because your y values are all positive. But if your area is below the x-axis, guys, your y values are all negative. If your y value is negative, hello, if your y value is negative, when you integrate, the result is going to be negative. So every time you integrate a function like this, right, if you get negative, we know area can't be negative. If your area can't be negative, what do you do? You modulus it, or you can put a negative in front, say something like that. Okay, but what if part of the graph is above? Part of the graph, oh no. Oh, what happened? Okay, let's say part of the graph is above, part of the graph is below, then what do? You have to integrate them separately. The one above is positive, the one below is negative. If it's negative, what do? You either modulus it or you put a negative in front. Okay, understand? All right. Okay. Okay. I think I need to reload this. 1 minute. I think this is all about writing integration notation. A very easy question. Okay. Now, so write the integration notation for the area for each of the following. Okay. First one. See, where is A1? Where's A1? A1 is here, right? Can you see? So how do you write an integration notation? We write integration of 4 to 5. 4 is a lower limit, 5 is upper limit. Your function is gx, you put dx. So that's your answer. Is this all right? Okay, how about A2? Now this A2, notice it is below the x-axis. Right, Edison? Below the x-axis is negative. So we have to put 1 to 4 gx dx. Now you either put a modulus or you put a negative. You can also put a modulus because it's not thin. Yeah, you can put a modulus, it's the same thing. Okay, the third one, your A3 is over here. Now, doesn't matter whether the graph's on the left or right, doesn't matter what, because your x, the main thing is your y value is positive. If your y value is positive, when you integrate, it's just going to be positive. So this is negative 1 to 1. Your function is gx. Yeah, no problem. That's all right. Hey, too easy. Insulting intelligence. Just the differentiation notation. Guys, the first one. Okay, where's A1? A1 is over here. So we integrate 0 to 1 fx dx. A2 is over here. Integrate -2 to 0 fx dx. A3 is below here. So the negative in front, 3 to 5 fx dx. Okay, that's all. Only the one that's below you put a negative, the rest no need. I will have to integrate. Now this one is negative 5 to 0. The area is already given. Just now you're supposed to find the area, given the integration notation. So here you're finding the integration notation. The area is 12. So is this just 12? Yes. Okay, the second one is a bit tricky because you can see, it's negative, it's below. Now, okay, I want to ask you a question. Can area be negative? No. Can integration be negative? Yes. So this area is positive 5, but the integration value is negative 5. Why is it negative? Because your y value is negative. No. Your integration value is negative. Okay, I say this again. If you put the area, then you put a negative, then you put a modulus 0 to 3 fx dx. This result, yes, is negative 5. But since area is always positive, you modulus it becomes 5. But now we're working backwards. This area, can you see this area is positive 5? Read the question. The diagram shows the area for each region bounded by the curve. This area is 5. Right not? But the integration value is negative. So you modulus, yes, you are getting 5. But now we are not finding the area, you're finding the integration value. Yeah? Okay, or the integral. Okay, so the second one. So when we integrate this, this one's a bit more tricky. No, because this is, oh yes, negative 3, correct. You've got to break it up. Yes, sorry. Yes, sorry. So this is 0 to 3 and then followed by 3 to 4. Now 0 to 3 is going to be negative. Why? Below what? We already got this earlier at negative 5. Now 3 to 4 is what? 3 to 4 is 2. Answer, negative 3. Hello? Yes. Okay. So the first part, integration negative 1 to 2 gx dx. Okay. Now this one a bit interesting. Negative 1 to 2. Do you count one by one? Okay, you can negative 1 to 0, and then 0 to 2. Right now, negative 1 to 0 is basically this area here. Can you see? It's 1, right? 0 to 2 is just 6, right? What's your total area? 7. Okay, how about negative 3 to negative 1? Negative 3, negative 1 is here. But the area is below. If the area is below, you put a negative. Remember, your integration value can be negative, but the area is always positive. Okay, the last one. Negative 3 to 0. Okay, negative 3 to 0, we just have to break it up. Negative 3 to negative 1. Okay, I break it up first. And then negative 1 to 0. But this negative is better. Okay, this is actually a 1 mark question. Now, if they give you 2 marks, you show more working. And this is negative 7. You know, this is 1 answer, negative 6. Isn't it? Yes. Yep. Example is example number 30. Now remember, if you want to find area under the graph, so this graph is bounded by the curve, the x-axis, and y equals to x equals to 2, x equals to 4. So this is how you write it. We write the lower limit 2, the upper limit 4, your y is 2x squared, your x-axis is just dx. Okay, so when you integrate, we copy 2, you copy x, increase the power by 1, 3, divide by 3, lower limits 2, upper limits 4. Okay, so now I need to substitute inside. So when you put 4 inside your x, 4 power 3, can I 3 recount? What is 4 power 3? 64, right? And then I put 2 inside, 2 power 3 is 8. So 64 minus 8 is 56, right? 56 times 2, 112. You divide by 3. Divide by 3 now. 30, is it 37, 1 over 3? Yes. Now, it's just square unit with x. Am I right? Yes. Okay, second one. Now, although this area is on the left-hand side of the y-axis, it doesn't matter, because what matters is if your y is negative. If it's below the x-axis, the y value is negative, then your area is negative. But here my area is going to be positive, so I integrate from -3 to 0. My function is 4 over x minus 2 squared dx. So as I integrate, we put a negative in front, I copy 4, I copy x minus 2. Now here we have to reduce the power by 1. Guys, still remember this formula, the shortcut method. Yeah, maybe I write down a formula for you. In the event that the bracket is below, when we integrate, we put a negative in front, we copy k, we copy ax plus b, reduce the power by 1, put the reduced power in front, and differentiate inside. So here my reduced power is 1, 2 minus 1 is 1. You don't need to write the 1 in front. When you differentiate, it's still 1. Yeah, so you don't write. So lower limit is -3, upper limit is 0. Now be careful with composite function. Now, when you have a bracket, right, please don't think that we put 0 inside, you get 0. It's not 0. So if you put 0 inside, you actually get -2, right? And there's a minus here. If I put -3 inside, -3 minus 2 is -5. So what we have here, we want to write is 2 minus 4 over 5, answer 1 over 5. Now you can write as 6 over 5, but I personally find mensuration type like area, volume, length, mixed number actually make more sense. If I write, for example, I write 6 over 5, 6 over 5, your brain cannot register what is the number, right, the value. But when you say it's 1 over 5, we know, okay, it's slightly more than 1, right? So that's why I always give my answer in mixed number rather than in proper fraction. Area for C. So for C, right, you notice your graph here, the area shaded region is below the x-axis. Below the x-axis, your area is negative. Yeah, I mean your integration is negative. So, but area can never be negative. So we need to either modulus it or put the negative in front. Now, I personally like to put the negative in front because modulus a lot more things to write, and every line you put modulus, very troublesome. Just put negative in front. Now, if you're not sure, right, you just integrate. If you get negative answer, just modulus it. You can just write that. You may just integrate, get your answer, -10, then just modulus it, a equals to 10. Yeah, you can do that. Let me go on, sorry. So let's put a negative in front, copy 2x minus 7, increase the power by 1, 4, divide by 4, differentiate inside 2, 1 to 3. Can I not? Yeah?
Yes.
So from here, let us take out -1 over 8. So put 3 inside. Now, guys, when I put 3 inside, now I don't like to do a lot of work. I like to take, I hope you guys can do this mentally. 2 times 3 is 6. 6 minus 7, -1. -1 power 4, 1. Is that okay or not? Can you do that? Okay, some people say that you cannot. Okay, so 3 first. 2 times 3 is 6. All right, like this for you, okay? Then I put 2 times 1 is 2. All right, this can. So the first answer is going to be 1. Second answer is -5 power 4, which is 625. Now, 625, you minus 1 is -624. 624, you divide by 8. Can you divide 8 or not? 312 divide by 4. What is that?
78.
7. 28, 3, 3, 2. 78, right?
Yes.
Am I right? Okay. Now, okay, this is also not difficult, right? Yeah. But part C, you notice part of the graph, part D, sorry, part of the graph is above, part of the graph is below. Remember last week we talked about this. If you're going to integrate this result is going to be negative. This result is going to be positive. So you have to do part by part. All right. So this part here is going to be negative. This part here is going to be positive. So this is x power 3 over 3, x power 2, 0 to 2. This is x power 3 over 3, x power 2, 2 to 3. Okay, from here, we are going to sub 2 inside. 2 power 3 is 8. 2 power 2 is 4. Okay, 0 inside. Second one, 3 power 3 is 27. 27 divided by 3, can I write 9? Yeah, Imagine this, I put 3 inside 3 power 3 is 27, 27 divided 3 is 9. Put 3 inside 3 power 2 is still 9. Let's put 2 inside. Now this one, you just close your eyes and do, sorry, you close your eyes, you can't see. You just copy this and put here, because it's the same thing, I'm putting 2 inside. Yeah? Am I right? So now let's count. It says, what is 8 over 3 minus 4? So it's 8 minus 12, negative 4, right? But there's a negative here, so it's negative 4 over 3. This will be a positive. This will be a 0 here, and another negative 4 over 3. So basically 4 over 3 plus 4 over 3, which is 8 over 3. And 8 over 3 is 2 over 3. Yes or yes?
Teacher, I choose no.
When you want to find the area, or you're talking about these two doesn't matter, I don't need to show one. It doesn't affect anything. So when you integrate 1 to 3, your function is 3x squared plus 2 dx. So here you get x3 divided by 3. The 3 cancel out. Integrate 2, you get 2x. Lower limit's 1, upper limit's 3. If you sub 3 inside 3 power 3 is 27. When you put 3 inside here, you get 6. I put 1 inside, get 1 and 2. So this will be 33 minus 10 minus 3, 30 square unit. You have to use composite function. And when you integrate from negative 3 to 0, one shot. Don't have to do part by part, just do one shot. The lower limit is minus 3, upper limit is 0. This is involving composite function. So we copy the bracket, increase the power by 1, 3, divide by 3. Now, when you differentiate 4x, remember to differentiate inside the bracket as a 4. Yeah, divide it. Lower limit is minus 3, upper limit 0. So this is 1 over 12. Let's put 0 inside. You get 0 plus 5, power 3. Now, if you put negative 3 inside here, you get negative 12 plus 5, power 3. This is a big number, right? So what is 5 power 3? 1, 2, 5, right? So the second one is negative 7 power 3, which is negative 3, 4, 3. Now, what is 1, 2, 5 plus 3, 4, 3? 460. 68, right? 46 divided by 3. I can use 36. So there's a 108. 108 is 9. Correct? Yep. C and D. Yeah. Okay. So not difficult, right? I hope. So this question, you have to put the negative in front. Why? Because the area is below the x-axis. So put a negative in front. Lower limit is 2, upper limit is 4. So this is 8 over x squared minus 2 dx. Okay. So when the x is below, put a negative in front, copy 8, copy x, reduce the power by 1. So please remember the technique I taught you to integrate this quickly is by putting a negative in front, copy a, copy x, reduce the power by 1, put the reduced power in front. So this is what I did. I put a negative in front, copy x, reduce 2 minus 1 is 1, just put a 1 in front. You don't write, it's okay. This is minus 2x from 2 to 4. So this negative, maybe I just times inside to make everything positive. So I put 4 inside. So this is positive now. Then if I put 2 inside, this is what I'll be getting. So this is 2 plus 8 minus 4 plus 4. Answer is just 2 square units. Okay? So okay, right? Manageable. Okay, the one that is more difficult is the last one because you have to integrate 1 by 1. So the one on top is minus 1 to 0. Now my function is x power 3 minus x power 2 minus 2x dx. The one that's below is this region here. Put a negative in front, copy 0, 2. This is x cubed minus x squared minus 2x dx. Basically, you just copy the same expression. Okay, so when you integrate the first one, you get x4 over 4. Integrate x cubed, x squared, you get x cubed over 3. Integrate 2x, you get x. Lower limit minus 1, upper limit 0. So you're lazy, right? Don't need to integrate, just copy because it's the same thing. Yeah, it is the same thing as part A. So now let's put 0 inside. The good news is if I put 0 inside, the whole thing will still be 0. But when I put -1 inside, I don't get 0. This one is -1 power 4 is still 1. Okay, sorry, I made a mistake. Thank you, Brian. X squared. You're very sharp. Now this is -1 cubed is negative, negative, positive, right? This is still negative. Am I right? Because -1 you square it is positive. Okay. Now next, let's put 2 inside. 2 power 4, 16. 2 power 3, 8. 2 power 2 is 4. Put 0 inside. So this is 1/4 plus 1/3 is 7/12. 7 over 12 minus 1 is -5/12. Right? If you can't use brain, use calculator. Okay, the second one will be 16/4 is 4. 440. This will be 8/3. Right? So 5/12 plus. Okay, 8/3 I can times 4. When I times 4, top and bottom, I get 32/12. This is 37/12 or 3/1/12. Am I right? Yes or no?
Yes.
We previously dealt with area bounded by x-axis. So now we're going to move on to area bounded by y-axis. So the difference between x and y-axis is that x-axis, right, when you integrate, so let's say you have y in terms of x. So when you integrate, you move towards the x-axis. The lower limit is a, upper limit is b. So we write this as integration of a to b y dx. But this function, we can rewrite it. We can instead make x as a subject. So when you make x as a subject, we move this over here. Let's say this is p, this is q, right? This is your function. Now we move towards the y-axis. So this area is now integration p to q x dy. Yeah. Now similar to y-axis, right? Similar to integration x-axis. In x-axis, if the area is below, is negative. Below x-axis is negative because your y is negative. Now for integration with respect to y-axis, it's the same thing. When your area is on the left-hand side, let's say the lower limit is a, upper limit is b, right? So if you go and integrate a to b, x dy here, you'll be getting this region. But this region is on the left-hand side. Your x value is negative. So when you integrate, your answer will be negative. So to make it positive, you either put the negative in front or you put a modulus in front. And also, if let's say part of the graph is on the left, part of the graph is on the right, say this is a to b, b to c. So a to b is going to be negative. So you need to put a negative in front. B to c is going to be positive. So we just integrate separately. Then only you them up. Okay, huh? Not difficult, right? So whatever I've said is already written here. So look at this one. The first one, the formula. Second one is if it's negative, right? And third one, if part of it is on the left, oops, part of it on the right, part of it on the left, just integrate separately. Modulus or put a negative in front for the one that's negative. Okay. Okay, guys, let's move on to example number 31. So in this example, you're supposed to find area of the shaded region, yeah, bounded by the y-axis. So the first question, you're given x equals to y squared over 4. And you can see here, this is bounded by the y-axis here. So when you integrate this, you move towards the y-axis. Yeah, your area is bounded by lower limit 0, upper limit 3. Your function x is y squared over 4 dy. So when you integrate, you copy y, increase the power by 1, 3, divide by 3, 4 times 3, this will give us 12. Lower limit 0, upper limit 3. So when it's up 3 inside, 3 power 3 is 27. 27 divided by 12, then you minus 0. Now 27 over 12 is basically 9 over 4. You don't have to write all this, you can straight away change your mixed number to 1 over 4. Okay. Now it's okay to leave your answer as improper fraction, but mixed number, in my opinion, will be better. Yeah. for mensuration like length, area. Yeah, it makes more sense of writing your answer in mixed number. Okay, let's move on to B. Here, your lower limit is -1, upper limit is 1. Yeah. The function is 3y plus 5 to the power 3. So when you integrate, you copy the bracket, increase the power by 1, 4, divide by 4, differentiate inside 3, lower limit -1, upper limit is 1. So I'm going to continue here. So I think perhaps it's better we take out 1/12, right? You can see here, this is 12 here, 4 times 3 is 12, but just take it out as 1/12. Then if you put 1 inside, 3 times 1 is, when you sub 1 inside your y, 3 times 1 is 3, 3 plus 5 is 8. So this is 8 power 4. And when you sub -1 inside, you get -1 times 3 is -3, -3 plus 5 is 2, and you have 2 power 4. Now you might use calculator here. 8 power 4 minus 2 power 4. Whatever you get, divided by 12. I got 340. Okay. All right, hurry up. I'm going to move on to part C and D. Okay, let's move on to part C here. I hope you're done. So for part C, you notice area is on the left-hand side of the y-axis. If it's on the left-hand side of the y-axis, when you integrate, the result will be negative. Now, since area cannot be negative, yeah, we either put a negative in front here, or you can put a modulus. Yeah, it's the same thing. So I'm going to put a negative in front. My lower limit is -2, upper limit is -1. Now I need to make x a subject. You can see here y squared is -3x. If I transfer the -3 down, your x is y squared over -3. So you need to put a y squared over -3 here, dy. And for me, since there's double negative here, might as well cancel negative, right? And immediately I integrate this. When you integrate y squared, you increase the power by 1, you get 3. 3 times 3, I'm going to write 9. Lower limit is -2. Upper limit is -1. Now, let us substitute -1 inside. -1 over 9. Okay, -1 power 3 is still -1. And if I put -2 inside here, you get -8. -2 power 3 is -8 over 9. So when you subtract, +8 minus 1 is 7. 7 over 9 square unit. As for part D, you can see this part of it is on the right. This part is on the left. So when you have part of the graph on the right, part of the graph on the left, you got to separate them and integrate them one by one. So the one on the right is positive 1 to 2, 4 over y square minus 1 dy. The one on the left, either you put a negative or you put a modulus, up to you. So I'll put a negative here. From 2 to 4, 4 over y square minus 1 dy. So when you integrate, put a negative in front, copy 4, copy y. Remember, reduce the power by 1 is 1, put a 1 in front. When you integrate -1, you get -y. Lower limit is 1, upper limit is 2. Okay, again, the second one, you can just copy because it's the same thing. Lower limit 2, upper limit 4. So when I put 2 and sub inside here, you will get -4 over 2 minus 2. If I put 1 sub inside here, you get -4 over 1 minus 1. Now you repeat with the second one, but this time your upper limit is 4. 4 over 4. There's a 4 here. Put 2 inside here. So -4 over 2 minus 2. Okay, this is going to give us -2 minus 2, which is -4. This is -4 minus 1, which is -5. Minus is a +5. I keep this negative first. This is going to give us -1 minus 4, which is -5. And this will be -2 minus 2 with another negative, so it's a +4. So what we're getting here is a 1 minus -1. That means that this area is 1. This area, when you integrate, is negative, but then when you modulus it, or you put a negative in front, it becomes 1. And your total area is just 2. The first part, we just integrate from 1 to 3, 6 over y power 3 dy. Put a negative in front, copy 6, copy y, reduce the power by 1, 2, put the 2 in front, 1, 2, 3. Yeah. I hope you're okay with this method of integration. So yeah. And we can cancel 6 and 2, left with 3. Put 3 inside, 3 squared is 9. Then you minus, put 1 inside, you get 1. So it's basically 3 minus 1 over 3 plus 3, 2 over 3. Okay? So let us just integrate the next one. From minus 2 to 1, your function is 2y plus 1 power 2 dy. So when I integrate this, I copy 2y plus 1, increase the power by 1, 3, divide by 3, differentiate, I get 2, minus 2 to 1. Okay, here I can take out 1 over 6, right? And I don't like to divide by 6, I just take it out, 1 over 6 is better. So you put 1 inside, this will be 2 plus 1, and this will be 2 times minus 2 is minus 4. You can catch up working on the right so long. This is 1 over 6, 3 power 3 is 27, minus 3 power 3 is also 27. So 27 plus 27 is what? 54, right? 54 divided by 6 is 9. Okay? So for part C, again, I make my question, oops, this is the wrong one. This one. I make it very similar to my C of my example, as in the area is on the left hand side, so you're going to put a negative in front, 2 to 3, 4 over 9, y power 3 minus 12 dy. So when I integrate this, this is going to be y power 4 divided by 4. When you divide by 4, you cancel with the 4 on top. When you integrate 12, you get 12y. Lower limit is 2, upper limit is 3. Okay? So let us put 3 inside. 3 power 3 is 81. 81 divided by 9 is still 9. 12 times 3 is 36. 2 power 4 is 16, right? 16 over 9. 12 times 2 is 24. Okay, who can help me? Nobody. So I will do this first. This will be 37, right? Plus 24. Then I minus 1. This is 7 over 9. Correct? Wow, very ugly, right? So it's negative 3, negative 4, 7 over 9. The negative will cancel out with negative. I will get positive. Correct or not? Yes? Okay, B. If you integrate these two separately, the one on the right is 0 to 1 y minus y squared dy. The one on the left, you put a negative in front, 1 to 2 y minus y squared dy. Okay, so this would be y squared over 2, y cubed over 3, 0 to 1. This will be y squared over 2, y cubed over 3, 1 to 2. Okay, so put 1 inside. 1 over 2 minus 1 over 3 minus 0. Let's put 2 inside. 2 squared is 4, 4 over 2. 2 cubed is 8, 8 over 3. 1 over 2, 1 over 3. Okay, this is going to give us 1 over 6. Right? Okay, this one is going to give us 2. Wow, a bit hard to comment to be right. 2 minus 8 over 3. So it's negative 2, negative 2 over 3, right? And then this is 9 minus 1 over 6. Correct or not? Wow, this is very long. So 1 over 6 plus 1 over 6, 1 over 3. 1 over 3 plus 2 over 3 is your answer 1. Yes. Let's look at the next one. Okay. Now area bounded by the curve, two curves. So now let's say you have a curve on top like this, and a curve below. They have the same boundary here. Can you see? So when you take the bigger area minus a smaller area, then you get the area in between. So basically, we just integrate them one by one. We subtract them. Okay. So somehow in exam, right? The common one, they always give you one geometric shape. Geometric shape means triangle, rectangle, trapezium. And then the second part, you have to use area of integration. So now we look at example number 32. So you want the area bounded by straight line and this curve. So I need to understand this. We need to take a straight line, and then you move down towards the x-axis. Okay, let me draw a smaller version, too big. You take this line, you move down towards the x-axis. What do you see? This is 3. This is 4. Guys, what do you see here? You get a trapezium, am I right? Move the straight line down towards the x-axis. Where this is 0, this is 3, this is 1. So maybe I write this as 1, and this is 4. Perhaps I'll just write this as 3 because the length is now 3. Now, as for this curve here, when you integrate respect to x, you're actually getting a shape like this, right? So we are actually integrating or getting this area here. Can you see that? So by taking the trapezium minus the area of integration there, you should get this area over here, right? Now, area of trapezium is given by half sum of parallel sides times height. Then you minus integration 0 to 3. And my curve is x minus 1 squared dx. Okay, so this will be 15 over 2. When you integrate this, is x minus 1. Increase the power by 1, 3. Divide by 3. Now, when you differentiate x, you still get 1. There's a 1 here. The one right is okay. 0 to 3. So 15 over 2, we'll just leave this 15 over 2. This one, I will put 3 inside. 3 minus 1 is 2. All right? 2 power 3, you can write 8. But be careful, when I put 0 inside your composite function, as I say, it's not going to be 0 because 0 minus 1 is negative 1. So this is a negative 1 power 3 here. So this is 15 over 2 minus 8 minus 1, which is 9. 9 over 3 is 3. So this will give us 15 minus 6, which is 9 over 2, or 4.5 square units. Okay. The first thing is, look at who is bigger now. The bigger one is the curve. The curve is actually bigger. See, this is a curve. When you integrate, move down, you get a shape like this. So this is the curve. Now, the second one is your straight line. When you integrate down, you're actually getting a triangle. Fair enough. So this curve you have to integrate from 0 to 2. This triangle has a base of 2, height of 8. So your area will be integration 0 to 2 x squared plus 4 dx minus half times base times height. So from here, when you integrate this, you get x power 3 over 3. I can use dy. I wouldn't use dy, Nikhil, because if you use dy, you need to make x as a subject. And when you make x as a subject, right, see, x squared is now y minus 4. So x will be square root y minus 4. And when you do that, you got to put a plus minus, right? So yes, I know some of you know this is the positive part, but this can be the negative part. So just be careful when you do this. So for me, if you're given y as a subject, so I integrate respect to y. If you're given x as a subject, I'll integrate respect to x. That will be the most clear cut. Because this, when I integrate respect to y, respect to x, it also looks about the same. Should I say respect to y is harder in this case, right? Okay, anyhow, let's continue. When I integrate this, I get 4x, lower limit 0, upper limit 2. This is 8. So if I put 2 inside, 2 power 3 is 8 over 3. 2 times 4 is also 8. 2 times 4 is 8. You minus 0, minus 8 again. So after you subtract with 8, you're left with 8 over 3, or 2 over 3 square units. Integrate respect to y. Like I said, the one on the right is bigger. In this case, this is on the right. You integrate it, you get a shape like this. The one on the left, smaller, you get like this. When you subtract, you get the area in between. Okay, so let's look at one example. Example 33. So the one on the right is a straight line. See that? You move over to the left, you get a trapezium like this. Okay, now this trapezium, I can see that at x-axis, guys, at x-axis, your y is 0. So if I sub y equals 0 inside here, or even inside here, my x is going to be 1, right? So this is 1. So I know the length from here to here is 1. And if I draw a line here, this is 2, this is 1. So the width, the parallel side will be 1 and 2. Height will be 1. Now, for the curve here, when you integrate this curve, okay, maybe I highlight. Looks like this, right? And you have to integrate from 0 to 1. Now your function is already given, x is y squared plus 1. So let's use area trapezium, half sum of parallel sides times height, minus integration 0 to 1. Now my function is y squared plus 1 dy here. So this is 3 over 2. This will be y cubed over 3 plus y, lower limit 0, upper limit 1. So if I sub 1 inside, I get 1 over 3. If I put 1 inside, I get 1. If I put 0 inside, I get 0. This is 3 over 2 minus 4 over 3 is 9 minus 8 over 6, which is 1 over 6. All right. I'll give you some hint and I'll give you answer. The answer is 6 over 3. But you need a big hint here because I don't want you guys to, use the wrong shape. Now, you notice this point is you cannot take all the way down to the x-axis because you notice that there's a small part there that's not involved. So we need to move over here. This is 1, right? This is 8, right? So the one above is actually a triangle here. But this triangle, when you measure from here to here, is actually 5 minus 1 or 4. This is 8. Then you minus this area of integration 1 to 3. Can you see that? Yeah? Okay. Yeah, you can just use area triangle, half times base times height. Now, take note, this is not 5, but this is 4. 5 is all the way down. You're not taking all the way down, you're taking up to here, yeah? Because they meet at this point. And then you integrate from 1 to 3. Your function is this one, 9 minus y squared dy. Okay, please continue. So the first one, you cancel, then you get 16. This is 9y cubed over 3, 1 to 3. So let's put 9 times 3, 27. 3 power 3 is 27 divided by 3 is still 9, right? This is 9 minus 1 over 3. Okay, so 27 minus 9 minus 9. So it's 9, 9. Then you minus plus 1 over 3. Right now. So you get 6 over 3. Okay, so combination of two area, right? So previously is one above, one below. So we subtract to get the area in between. Now we have two different equations, one on the left, on the right, we add them up. So this is actually easier than the earlier one. See, one on the left, one on the right, just integrate them separately, add them up, yeah, and get the total area. So one example 34. Okay, you can see this is a straight line. Okay, this is 2, this is 1. So the one on the left will be area of triangle. So I'll just draw this triangle for you. You can see this is 2, the measurement, the height is 1. The second part is integration. We have to integrate from 2 to 3 of this function. So the triangle, if you want to go and integrate this function, you can. But I think integration is longer. Half times base times height is so fast. We straight away get the answer. The answer is 1, right? So the second one, we integrate from 2 to 3. My function is now 4 over x squared dx. Okay, so this is 1. When you integrate this, is negative 4 over x. Lower limits 2, upper limits 3. So let us put 3 inside. You get 4 over 3 minus negative 4 over 2. Okay or not? So this is going to give us 1. Okay, negative 4 over 3. Oops. Negative 4 over 3 if you plus 2. Plus 2. So basically, we are taking 3 minus, maybe you can think, okay, 3 minus 1 over 3. So it's 1, 2 over 3. Am I right? Yeah. Okay. What you should do is split this into 2, right? This is the area integration, 0 to 1. You're going to integrate this function here. Now, the height here is up to 3. So all the points are all given, but sometimes in exam, they'll ask you to find like the coordinate intersection. So here, no data, they're all given here. So we just add area triangle. Like, look at this triangle, 1 to 4. This is 3. This is also 3. So we're going to integrate from 0 to 1. My function is x squared plus 2 dx. My area triangle is half times base times height. Okay? You all can get the answer or not? 656. Yes. Yes, good. So here we integrate x power 3 over 3. This is 2x. Lower limit 0, upper limit 1. This is just 9 over 2. So if I put 1 inside, I get 1 over 3. If I put 1 inside x, I get 2. This is 0. I'll just leave it as 9 over 2. So, okay, or maybe we can think 4.5. 2 plus 4 is 6. Now, 1 over 3, when you plus with 1 over 2, you get 5 over 6. So this is 5 over 6, right? Square units. Area bounded by y-axis. Yeah, we move towards the y-axis. So now, same thing, you just add up the two different areas. So this area, A to B, then B to C, just add them up, okay? So let's look at one example, example 35. So the thing is, you got to identify the shape here. So the first shape that we have, if you move the dotted line down, this is 3. Now, it doesn't look like 3, 3, but it is. My diagram is not drawn according to scale. So this is like a triangle. And then you integrate from 3 to 4. Oops. Where are they? One more time. 3 to 4. Okay. So because one thing we know, because this is x is given as subject. Now I know some people say, oh, Terry, what if I just integrate like this and minus this? Can or not? Can. The problem is you need to make y as a subject, which will be difficult, right? It's not impossible, it's difficult. You can. What do you need to do? You need to take out the negative, y squared minus 4y, and we need to complete the square, half of it, y minus 2 squared minus 4. So this will be negative y minus 2 squared plus 4, y minus 2, oh, this will be super long, square equals to 4 minus x, then you square root. And when you square root, you got to consider plus and minus, guys. Why not? So is this a plus or minus? A question mark, right? This is supposed to be a plus at the top one. So then your y will be just 2 plus square root 4 minus x. Now that will be difficult, right? So this is why I'm telling you, if your x is given as a subject, we integrate respect to y. If your y is given as subject, we integrate respect to x. That would be easier, right? No need to think very hard. Yeah, here, if you were to integrate respect to x, we have to rearrange the equation, yeah, which is a lot more difficult. Okay, so now let's just add them up. Okay, so the first part, I use area triangle, half times base times height. Second part, I integrate from 3 to 4. My function is 4y minus y squared dy. So this is 9 over 2. This is 2y squared, y cubed over 3, 3 to 4. Now, let's substitute inside. 4 squared is 16. 16 times 2, 32, right? And the second one, 4 cubed is 64. 64 divided by 3. 3 squared is 9. 9 times 2, 18. 3 cubed is 27. 27 divided by 3, 9. Okay, this number is a bit ugly, right? So 9 over 2. Okay, 32, 96, 32 over 3. Right now. Then you minus 9. Oh man, this is long. 9 minus 9 to 32 over 3. I think, okay, I'll put 32 over 3 first. This is 9 over 2. So it's 64 minus 27. Man, 64 minus 27 divided 6. Maybe I shouldn't have done that. Very long. 31, 37 over 6. 6, 1 over 6. Yeah. So you can see I can draw a line here. This is minus 1 to 1. So your area integration is minus 1 to 1. And your x is given as a subject. So this is a triangle. You can see that this triangle has base of 4. Height 3 minus 1 is 2. So your area integration is from minus 1 to 1. The function is y plus 1 squared dy. Now for your triangle is area. Your area is half times base times height. Yeah, correct, Jen? So here, when you integrate, you copy the bracket. You increase the power by 1, 3. Divide by 3. Differentiate inside is 1. Lower limits minus 1. Upper limits 1. Now area triangle you can cancel, get 4. Cancel the 2, get 4. Now I like to take out 1 over 3. Put 1 inside. Now when you sub 1 inside, 1 plus 1 is 2. 2 power 3 is 8. When you put negative 1 inside, you get 0. So you get 8 over 3 plus 4. 8 over 3 is 2, 2 over 3. When you plus 4, you get 6, 2 over 3. Okay. This is the case, right? What we have to do now, a lot of people, okay, maybe a lot of people, they get confused when they see part of the graph above, part of the graph below the x-axis. Actually, it doesn't matter. So this is A, this is, okay, maybe I better show you this diagram, okay? So look at this diagram again. Yeah, part of the graph below, part of the graph above. So you can have 3 parts of it. The first part is your A1. A1 will be this part here. Can you see this part here? Minus B to C. So it's actually area A to C minus B to C. Then A2 is integration from A to B, but A2 is below the x-axis. Below the x-axis, if you integrate, you're going to get negative. So to find this area, we just add them up. It's basically this 2 plus this. Can you see? Plus a negative. Now, the reason why I had to put a negative is because it's below. When you integrate, you get a negative answer. So these 2 negative, I can put it together, factorize it. And remember in the previous part, the integration, the one with the limit, I say A to B, B to C, you can combine to A to C. So the bottom line is, doesn't matter whether part of it is above, part is below the x-axis. You just take the bigger one minus the smaller one. Now imagine this, okay? If I give you a curve, another curve, right? So the bigger one is y equals fx. The smaller one is y equals gx. So if you were to find area under the graph, so what do? We say A to B fx dx minus A to B gx dx. But let's say suddenly I take the same shape, but I put it here. Yeah, this is where a lot of people get confused. I put it like this. Now you notice this is still A to B, but part of this area is below, part of the area is on top. But does the area change or not? Does the magnitude of area change? No, right? Even if I take this and I move it up, I shift it up like this, or even I shift it down like this, it doesn't change. So you will still have to find the area by taking the bigger one minus the smaller one. The bigger one being fx, smaller one gx. So it doesn't matter whether part of it above below x-axis. We just integrate as usual. Yeah, by taking the bigger minus the smaller.
Hi guys, I hope you've learned a lot from the video presentation just now. If you wish to have more access to all our videos, you can find out more from our website at www.teliti.edu.my. As you can see here, this is from our website here. We have e-courses, timetable, registration. Yeah, you can join our tuition class if you want. Yeah, you can book a trial class, talk to my staff, yeah, arranged for lesson here. Or if you are interested in our just purely our e-courses, click on the tab on the top left, yeah, and as you can see here, we have e-courses at your fingertips, right? We cover a comprehensive syllabus. As you can see from my video, I go through a lot of examples with the student so that to ensure students understand, we cover a lot of exam oriented questions so that the students are able to do it during exam. Alright, our material quite comprehensive, I would say, and is updated with the latest SPM KSSM syllabus, right? So you can study at your own pace and study at the comfort of your own home, right? So if your teacher in school are really fast, then you want to catch up with school, you can actually view the video ahead, alright? And if you have problem with the previous chapter, you can always view back and learn at your own pace. And this video are particularly helpful when it comes to exam. Closer to exam, if you want to revise the whole syllabus, you can always view the video one by one and be specific. Read and view the video that you need particular help. Alright, so I'm going to show you one example on how our Form 4 module works. So you, as you purchase this module, you will actually get 4 books, right? Each book comes with a hard copy book delivered directly to your doorstep. Each book has about 2 to 3 chapters. For example, book 1, function and quadratic function, book 2, system of equation, indices and logarithm, and so forth. Now, the book does not only come with note example and self-test, it has tutorial as well. Some additional question that you can do after you finish your example and self-test. Yeah, you should do your tutorial to enhance your understanding and to remember whatever you have learned, right? And the tutorial also come with a set of answers, right? Okay, so if you're interested, you can make a purchase through our order form here, right? As you can see. Now, once you have ordered, right, we will direct you to our e-learning site. All right, this is some example of an e-learning site. You click on login. You'll be given a username and a password as you log in. Okay. Okay, you go to our dashboard. Let's say SPM Form 4. All right, so you go to classes. Now, classes is for our regular class. E-courses is for our this whole module. So go to e-courses, click on Form 4 additional mathematics, right? So I'm going to show you one example. Click on the first module. You can see here you have function, chapter 1 function, lesson 1, lesson 2, 3, and 4. So every chapter is different because some chapters are longer, some are shorter, but basically you break down into lesson. And one lesson is about 10 to 20 example depending on the content, and it's basically what you learn in 1 week, right? So for example, when you click on lesson 1, you can see lesson 1, 14 example, you have to go through the example and self-test. So what I'll encourage a student to do is to start off by watching the video of the example. Okay, now, so this is a video example. So now, after finish watching the example, you can copy the example if you want, and then start working on the self-test, because the self-test is similar to example as you've seen from our previous video. And once you're done, view the self-test. Okay, and then check the answer. Yeah, so to ensure that you got the correct answer. All right. So once you finish all the 14 examples for this lesson, you flip the back of the chapter and start working on your tutorial. Yeah, the questions are similar. Tutorial 1, 2, 3 is the same as or similar to example 1, 2, 3. All right. So I hope you've learned a lot from this video presentation. And yep, if you're interested, you can order the module from us. Right. Thank you very much for watching. I'll see you guys in the next video. Bye bye.